All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the winter 2022 semester at George Brown, and it's week 7, part 2 of our broadcast and recording. And today we're doing the lab recording. Let's get moving and talk about where we're at. What is our goal for today? We have a lot of stuff to cover today, and of course, very little time. Our goal is really to find the shortest path. We're going to display the path list. Spawn object, although that was part of our thing that we wanted to do, we're not going to do this today. That's going to be left out for you to do. And generating random objects, obstacles to test pathfinding, that's for you to do as a bonus. So take a look at that on the lab report later on today. I'll be talking about that. But without further ado, let's get moving on the coding because there's a lot to do in very little time as normal. So let's bring this up. So again, up on courses. Desktop. In GBC, I'm going to go to your section, which is section 400. And we have lab 4. I'm going to make a brand new lab 5. Let's do that. And then inside of lab 4, I want to grab all this stuff. But one thing to note is that if I hover over lab 4, it's quite large. You can see that it's 98 megs. Here, you can see that this is 86 megs. Here you can see that this is 86 megs, and the other one is also like 72 megs. Let's start cleaning these up, and the way to clean them up is to go into the VS folder, into the template folder, and anything else you have in there, remove the vc.db, the database, and the IPCH files, please. Remove them from the previous code. And also, there's also something in v16, I think, right here. Remove those things, because what you need to do, if you go to the, in the template also, get rid of the intermediate folder. And it's going to cut the lab down to something that's reasonable, like 39 megs, as opposed to, something like 90 megs, right? So half the size, right? Now, I know it's not a big savings, but for me, when you upload to your stuff, as an example, to your, when you upload your stuff as a zip archive to Blackboard, it's really large, takes a long time to upload and all that kind of stuff. So what you do is you go into these folders and remove the intermediate files and the stuff inside the VS folder but not the SUO file. You keep the SUO file, you just get rid of the DB file and the IPCH files. These are called garbage files that we want to get rid of typically. So let's just refresh that. There we go. And those garbage files cause a bit of load for us as we move forward and push things up to GitHub. We don't want that to happen. So that's why I'm just going in here and removing them for you one at a time. So when you look at the template now, you'll see that the file size, when you download it, it's going to be smaller. And that's what I want to do. And I also don't want to copy those extra files over because they keep on accumulating size. Every time we copy something, now I can copy all this from lab 4, and I can put that into lab 5, and we have a clean template without extra garbage files. That's what we're doing here. Okay, that's why these things are the way they are. If that makes any sense to you. All right, so that's great. That's a good start, and we want to put all this up on GitHub immediately. So I'm going to go to GitHub Desktop, and that's where we're using for your stuff. There it is. And we'll target section 400. These are all the files. We'll say we added project files for lab 5. We'll commit to main, and we will push in a second when it feels like it. It's doing all this extra work because I just removed a bunch of stuff, all my template files. It's just re-indexing all those things as I push them to the origin remote. Awesome, I'm ready to go now, and I'm going to start off with my template by running Visual Studio. Lots of stuff to do today, and the first part of what we're going to do, of course, as always, the first part that we're going to do, as always, is test to see where we're at. I'm just going to close all these tabs down, close all tabs. And let's test to see where we're at. We're also going to rebuild our files this way because we just removed all the intermediate files and any garbage files. So we want to regenerate everything that we need to do locally so that we have everything we need. So again, that cleaning business that I showed you, people had asked, what do you mean by cleaning files? I still don't get it. I know that Alex had talked about this in your foundation class, right? Fundamentals. He talked about doing, removing garbage files, but some of you are still putting them up. So this is what we had last time, where we had a toggle grid, and when we move our objects around the grid, that's okay, right? As an example, if I was to, move our ship around, everything snaps to grid, but we have smart tiles. We can go from Euclidean distance, Manhattan distance, all those things are functional, and that's where we are right now, okay? But we want to take this further, of course. This is not what we want for today. Today, we're going to add more to it, and we can look at what Alex has put up here as a thing. So we're going to start with Lab 4. We've done all this. We've done our first commit. We've done this piece. Now we're going to prepare everything in playscene.h, and I'm going to do it slightly differently than the last class to save time. So I'm just going to go in here into the scenes playscene.h. We're going to start off with that. And in the playscene.h, what I'm going to do is we're going to start by adding some different pieces that we need for today, okay? So we've got the first part, which is building a grid and getting everything ready for pathfinding, computing tile costs and blah, blah. And these methods here are like, create our division scheme, which is our grid, right? That's what it is. And that's what it is. And compute tile costs, all the tile costs and all this kind of stuff create our stuff. And the next thing we want to do is we want to calculate the shortest path, right? And other related methods. And that's going to be like this. We need void m underscore find shortest path. That's what we're going to call it. We're also going to have void m underscore display path list. We're going to do that as well. And we're also going to m underscore reset pathfinding. Okay, we're going to do that. We're also going to m underscore reset. This is one of mine, reset simulation. We're going to talk about how to do that as well. So reset simulation, reset pathfinding, two different things. We're also going to have tile lists for pathfinding, okay? And that'll be standard vector of tile pointers, which we're going to call m underscore p open list. There's our open list. And these are right from our PowerPoints, right? Where we're going to say m underscore p close list. Okay, more tiles, m underscore p path list. So open list is the list that we're using. We're going to check everything that's in the open list. Closed list, we've kind of closed off those tiles because they're not the shortest path. And path list is the way we're going to march from one tile to the other. That's how that works. Okay. We still have our heuristic and our tile functions. That's nice. But we also need to move our ship around. So just down here, we're going to have our ship movement functions, which is first we need some kind of move counter, right? And let's just call this m underscore move counter, right? So it's a member variable. We also want a Boolean, which is m underscore ship is moving. We're going to track when the ship is moving. We're going to start it off at false. And we're going to initialize the move counter to 0. Think about this as the move counter. When we initialize to 0, it's going to be the first position on our board. The game, think about like our tile grid, our grid of tiles as a game board now, where we move our piece from one position to the next. Okay? And then finally, we're going to have a m underscore move ship method, which is going to move our ship from one position to the next. We also are going to have two static methods. I'm going to change this now. Static methods. We're going to do this right away. Where we have our start position methods, two static arrays. We're going to have our start position and static int, which is the goal position. And I want to replace the stuff that's in IMGUI with these here, as opposed to using the ones that we have right now in IMGUI. And that's where I'm going to start today, as opposed to what we already have. So this is our new structure, and I've added a listing of new methods here, here, and some additional things. Okay, so that's what we're having. That's where we start off with today. Okay, in the .h file, are you with me? Check mark if you're with me, X if you're not. Okay, a couple people put it. Let's see if we can get everyone going. We've got a few people here, and we're good to go. I'm also going to check the people that are on YouTube, see if there's anyone else that's there. Cool. Okay, excellent. All right, let's move on. So what I want to do now is I want to pull up my playscene.cpp. Thank you for that feedback, guys. My playscene.cpp, and let's update those things that we have. So I'm going to go into, from global scope, we're going to move into playscene, and I'm just going to pop right into the IMGUI function just to start right here. And in the IMGUI function, right now, kind of near the bottom for my start position and everything else, I have something that looks like this. What I really want to do is I want to use a start position that's part of my class, right? Which I just made. I made the start goal and that kind of stuff. And notice that it doesn't like this. It says no operator matches arguments of type int and resharp or unknown type. Doesn't know what this type is, right? So we're trying to initialize these two values. They're integers, right? And if I go back to the playscene.h, they're static integers. That's what they are, right? So it knows what they are, but it doesn't like this. So what it really likes is, I'm just going to copy paste this twice, just for a second. So copy paste this down here like this, and change these values. He wants us to separate these values. Let's separate these values out. And it wants us to do something that looks like this. So I want to have the y-axis for my spaceship here. Again, and some of you may ask, like, why are you doing this? Well, because we want to be able to track our spaceship position when we're moving it across. We want it to update here in IMGUI when we're moving it around. So that's why I'm doing this. It's kind of a prep step for what we're doing next. Okay, so those are the two pieces. Similarly, we want this to happen now. So we want to copy and paste this. So again, this is going to be 0 and 1. And we're going to kind of move those across to that equal this, and equal that. And we're going to say that MP target here is the x-axis and the y-axis. We're not initializing in the exact same way we did before. And that is what it should look like. And let's see if this works the way it is. Now, Alex did one more thing, but we're going to try this first and see what the effect is going to be if we did it this way. And it gives me an error. It says that unresolved symbol private static int playscene start position. It says it doesn't know what those things are. And the way to fix this issue is at the bottom, and this is what Alex has done for us, is to fix this problem, we're going to declare them for the reset function that we're going to be using at the bottom of the outside of the scene, almost like as a class initializer. We're going to do something that looks like this. We need to initialize them somewhere so that they're available to us to use statically. And that's just a C++ thing. Okay. I'm going to go back to the, thanks for Keep. I'm going to go back to the questions on YouTube in a second. So if I run this thing, let's try it out and let's see if it works. Now it's working. And just as before, we should be able to move our ship around in the grid and move our target around, no problem. But we're using the something that is available now through the entire class, right? Compared to what was only available here in IMGUI. All right, so that's what we've done first. So let's put that up on GitHub. So I'm going to say something like added start position and goal position to placing. So that's what we really did, right? So commit, and we're going to go push, and we're good to go for that one. So that's the first commit we're doing, okay? And I'm starting here because it'll set us up. We won't have to think about this anymore for the rest of the time together. I'm just going to check on YouTube now and see if there's any questions. I think we're still good. All right, excellent. So let's go back to the next piece. So now that we've done that, I want to focus on the pathfinding aspect. And now Alex has a different order that he's doing. So we added this part, methods for pathfinding, in the placing, vectors for tile, properties for the ship, and 2 static arrays for start and goal position instead of the ones that find an IM GUI in order to update the IM GUI after reset. He says he's decided to use these, and he's going to make sure to define at the end of the CPP, which we talked about. We did all of this right now. Next, it says add the definitions for the static int arrays at the bottom. We did that already. And now we're going to invoke m_moveship and update with appropriate check. Let's do that. So what that means is we're going to call the move method, but we haven't really implemented all the functions. I'm going to do that next. So going into my placing.h, I have all these functions that I have to implement. So I'm going to go to the placing.name. I'm going to click on the little light bulb, and I'm going to say generate definitions by declarations, which is going to be generating my find shortest path, display path list, reset pathfinding, all the stuff that we did last time, and click finish, which is going to make these stub functions for us to use. So I'm going to do the move ship. I want to move ship around the path. That's what I want to do next. That's what Alex is saying. Or we want to implement or call move ship from the update function. So in the update function, we don't have any way of moving the ship. And the way the ship is going to move is if the is moving Boolean is set to true. So we're going to say if m_ship is moving. If the ship is moving, then m_move ship. Right? We don't have that right now. And ship is moving is set to false, so that's not going to work. But it's okay because we've set this up. Again, this is all set up for us. Next, we want to hunt right back down here where we have all of our stubs. So the stubs are right in here, right? You can see them, by the way, too, here if you look. And we've got all of this started. But what I want to do before, of course, we can move anything or do anything, I want to start thinking about finding the shortest path. So Alex, this is where Alex and I, again, are doing things slightly different. He did this part. He wants to add buttons first. I'm going to do the shortest path first and then add buttons. Again, very similar to all this. But this takes the most time. This find shortest path thing takes the most time. It takes the most time to explain. And I'm going to work on this for the remainder of the time that we're together, pretty much. These other things are going to be a lot faster. Okay, and notice that there are some things for you to do when you add some tiles that are impassable and all that kind of stuff. We'll talk about those impassable tiles in a bit, okay? All right, and let's see if I can help you with some of this too. All right, so let's go to the first piece, which I want to go to, which is let's do the find shortest path method. So I'm going to jump right into this thing, and I want to start explaining a little bit of what this method does step by step. Okay, what this method does step by step. So first, in the find shortest path method, the first thing we want to do is we want to check if the path list is empty. Okay, that's pretty simple check. So we're going to say if, and we're going to say m_p path list, right, dot empty if it's empty. If it's empty, we can proceed. This is where we can find the shortest path. What if I called find the shortest path multiple times? Well, the path list isn't empty, and then it's going to mess us up. So we don't want that to happen. Then there's some steps we want to take. Step 1, I want to add the start position. And where do all these steps come from? Well, if you look inside the PowerPoint document that I gave you just recently, this week, you can see that on page 28, you can see that it talks about how to do A-star pathfinding. And the first thing is initialization, okay? initialization, where it initializes the start position and everything else. So really, step one is initialization, right? And initialization does a bunch of stuff. We have a tile pointer that is called start tile. And what we're going to do for initialization is we're going to say m underscore get tile. We're going to use the spaceship grid position. And the spaceship grid position is going to inform us where the start tile is. We're going to say that the start tile, right, we're going to set the tile status right away to open, right? So we're going to say an open tile status. And then I'm going to do m underscore p open list. I want the open list we're going to push back our start tile for the beginning to the open list. So that's the first thing we're going to do. This is all initialization, right? And let's take a look. So we initialized the open list. We did that, initialize the close list, and then we put the starting node, which is a start tile, on the open list, right? That's the first thing we're going to do. Even though it says step 1 and 2, this is really all initialization step. Step 2, after we've done initialization, right? One other thing we also want to do is the goal. We want to set that the goal is not found. Sorry, that's another part of initialization. We're going to say that goal found is equal to false. We're not going to say the goal is found right now. Again, this is all initialization and setup. All right. Step 2, we want to loop until the open list is empty or the goal is found. Okay, that's what we're going to do. So we're going to say while and not m underscore p open list dot empty, while the list is not empty, right? And the goal is not found, right? We're going to do this massive loop. Okay, so we initialized here. Initialization is we kind of added, we initialized in many ways the start and open lists and all that kind of stuff. And in the step 2, we're going to have some secondary steps. So we're going to say step 2A to A, right? Step 2A is going to be more initialization, right? Where we're going to initialize the minimum tile, or the minimum cost, if you will. We're going to set that up to calculate the minimum cost of the tile. The minimum distance is what we're looking at from each tile. So that is based on the tile cost. So we're going to say initialize variables for minimum distance. All right, so we're going to say something like auto min distance, right, is equal to infinity. Well, right now the minimum distance we're going to set to infinity because we're finding the minimum value, if you will, right? And we're going to say, let's have a tile pointer, which we're going to call the minimum tile, right? A tile with the minimum distance, right, to our goal. That's what that is. And then we're going to set up minimum tile index. We're going to set that up to 0. We're also going to have a counter, right? And that counter is going to be basically for all of our neighbor tiles. So our neighbor tiles is something we're going to check. We're going to check each neighbor tile. That's what we're going to do. And we're going to say how many neighbors we're going to check is going to depend on, because we're going to go through this list over and over again, right? We're going to go from one tile to the next tile. We're not going to do it recursively. We could do a recursive function here, but we're replacing the recursive function with a while loop, okay? So we don't use recursion because recursion can be a little bit mind-boggling for some. So we're going to say that the counter that we want is going to be for our neighbor. So we're going to basically go from one neighbor to the other. And depending on what neighbor we find as the minimum neighbor, that is going to be our neighbor count. or that's what this counter is. So we're going to call it neighbor count. Neighbor count, right? And we're going to count. Again, we set the counter as an example, the neighbor count to 0. So we're going to first start off with our first, kind of our first neighbor as 0, the 0th neighbor. We're going to set up a temporary vector, which is going to be a vector of tiles that we're going to call the neighbor list. And the neighbor list is going to be used for us to temporarily have all the neighbors that are valid that we're going to check. So only valid neighbors. And what do I mean by invalid neighbors? Let's talk about invalid neighbors. So invalid neighbors are neighbors that, for example, if I had my start, if it wasn't here, let's move this here from this to there, right? Here's our start, right? So imagine if we were here, we would have at least 2 invalid neighbors. We'd have an invalid neighbor here, and we'd have an invalid neighbor there. We're not going to check the tile cost here because those are null pointer, right? We'd have 2 valid neighbors we're checking, this one and this one. Those are the 2 valid neighbors, right? What if also I had some impassable tiles? If I had impassable tiles here and here, we would mark those with an I for impassable. Those 2 would be invalid neighbors. We wouldn't want to check the impassable tiles because, well, we can't go there. It's impassable. And you can think about it, if we use impassable tiles, and again, this is for you to do, let's suppose I make impassable tiles look like this. Well, what this should look like on the grid is something that looks like this. So maybe a black wall that is something that looks like this. So this is impassable tiles. So clearly I'm not going to check this one, and I'm not going to check this one because those are invalid. They're infinite distance, right? But I will check this one and this one. Those are the 2 tiles I'm going to check. Those are valid tiles. And so we need a mechanism to store the tiles we care about, not all of them, here, okay? And we're going to color our grid a little bit, just like this. Oops, cancel. I'm just using this example grid to help you out so you understand. So that's what we want to do. We want to create that minimum thing. That's what this neighbor list is for. It's a neighbor list for valid tiles, okay? Step 2B. Here's step 2B. We're going to kind of collect or decide on which neighbors to check. We're going to set all of our neighbors, starting with all of our neighbors that we want to check. So check valid neighbors. Okay, check valid neighbors. And what we're going to do is we're going to loop through each neighbor in kind of right winding order. That's what we're going to do. So that means top. Remember that whole thing? Right, bottom, left. Those are the neighbors we're going to check, and to see if any of those neighbors are valid. All right. So we're going to do a for loop, and we're going to say that we're going to go from here's our neighbor index, from index to number of neighbor tiles. Okay, that's what we're going to do. And we're going to say, here's how we're going to go. We're going to say we're going to have a const auto neighbor. We're going to set this up at the beginning where the neighbor that we're looking for is, let's look at this neighbor. And we're going to say that neighbor is m_p open list. And I'm going to look at the first member of the open list. So the current thing that I'm looking at, which is our current node, I'm going to get our neighbor tile, right? And I'm going to use, if I put in the index here, it's going to give me a bit of an error because even though the index is an integer and get neighbor tile is expecting a neighbor tile, which if you look inside the enumerations, neighbor tile is just a set of top, right, bottom, left, right? And you can see that these are also integer values, but they are not, integers are not neighbors, so we have to cast this as a neighbor tile, and we can use a static cast to do that. That looks something like this. All right, so this is just a friendly word that I'm going to use instead of me copying and pasting this over and over again. I'm just going to do this once. Okay, bit of an optimization. Here, what I'm going to say is if my neighbor that the neighbor that I'm looking at, if that is equal to null pointer, right? I don't want to look at it, right? Also, what other cases are there? Well, what if it's an impassable tile? This is for you. If I want to say, if I get the tile status, either one of these, if it's a null pointer, or if my neighbor's not a null pointer, but if it's impassable, if the tile status is impassable, right? Then I don't want to look at it. I don't want to even consider it as part of my list. We're just going to continue. So what this does is it ignores neighbors, right, that are not valid. That's what they are. They're not valid neighbors. We don't want to put them on the neighbor list, right? And our neighbor list, here's our neighbor list. We want to push back the neighbor that I'm looking at. So that's what I'm doing. I'm kind of sorting through. Step 2B is really adding only valid neighbors to the neighbor list, and that's what I should put here. Add only valid neighbors to the neighbor list. That's the one I want to look at, right? Anything beyond that, it doesn't make sense. I'm looking at stuff that I shouldn't because, again, I'm in some kind of position where I'm in the corner over here. I've got maybe a neighbor over here. If I was here that I don't want to look at, maybe down here. There's several cases where we don't care about, neighbors that are outside in the gutter area, right? Or if I have a neighbor that's an impassable neighbor, like a wall or a mountain or something, I don't want to look at those either because I'm not going to pathfind through them. I'm going to pathfind around them. Okay, that's what I'm going to do. So I'm not going to add those to the neighbor list at all. Okay, so now that I've decided which neighbors to add to the list, the next step is for every neighbor in the list, let's do the next step. So step 2C, for every neighbor in the neighbor list, what do I want to do? I want to check to see if that neighbor is the minimum neighbor, right? Check if it is the minimum neighbor, minimum distance. If it has the minimum distance to the goal, or I'll say alternatively, the neighbor could be the goal. All right, so that's an option. That's step 2C. So check to see if that is. So for every neighbor, which means a for each loop. A for each loop is a ranged for loop where we're looking at the neighbor list, and we're going to use the word neighbor here instead. So for every neighbor, and we'll say for every valid neighbor in the neighbor list, or a valid neighbor in the neighbor list, then what I want to do is, okay, step 2C1, right? Is check if the neighbor is not the goal. If the neighbor is not the goal, then continue, right? So if neighbor get tile status, right, is not equal to goal, it's not the goal, then, do stuff, right? Otherwise, right, in this case, if on the else it is the goal, so neighbor is the goal tile, well then what do we do there with the neighbor? We've set up some stuff, right? We want to track the minimum tile. Minimum tile is the tile that has the minimum cost, right? The minimum distance. So we'll set it up here. We'll say min tile, right, is the neighbor, right? We know that, okay? And we also want to add our neighbor to the path list. So path list, let's push back that min tile. Okay, that's what we want. And we also want to say that goal found is true. We want to be able to break out of our while loop, right? But at the same time, we also want to break out of this little for loop. So this break breaks out of our for loop, right? Because we say, well, we've checked through, and guess what? The one we're checking is the goal tile. So let's break out. That's what we're saying here, okay? So that's number one. And two, right? Two, what about if this is not the goal tile? Well, then now let's do some min-maxing. We'll say that min distance, right, is equal to the neighbor get tile costs, right? But only if and only if, let's go back. Before we do that, we'll say, first we'll check. We'll say if, let's check if our neighbor's tile cost is less than the minimum found so far, right? That's what we want to do. So we're going to check that first. We'll say if neighbor get tile costs is less than min. Well, that we know, and that's min distance, by the way. Min distance, okay? If we know our min distance starts off at infinity, right? Right, that's what we know. And so if we know it starts with infinity, we can say that the min distance then, if we found that it's smaller, and it would be in the beginning, is equal to our neighbor get tile cost. We know that that is true, right? So I'm going to copy paste that. And then our min tile then is equal to the neighbor, if that is true, right? And our min tile index is also equal to the neighbor count, right? Whatever the neighbor count is, in this case 0, right? Because you start off at 0. And of course, every other time, I want to increase the neighbor count, which is going to take us to the next neighbor. Okay. We can also do neighbor count plus plus is what I really want to do here. So we're going to increment the neighbor count. And why? Because I'm checking each neighbor. For each neighbor is what I'm doing here, right? So as I move forward, I'm going to say, well, my neighbor count is 1, 2, 3 in the list, whatever that neighbor list, the tile in the list is. Again, if I have one neighbor, then this is just going to exit out, because if I only have one neighbor, then it's most likely the goal, right? Or something else. All right, so that's what this does, this little for loop. And the for each loop that we're using right now is kind of a key thing to decide when it's minimum. Next, outside of the for loop, but not outside of the while loop, we're going to have step 2D. Step 2D is going to be something like remove references from the current tile in the open list, and we want to, add the, the current tile, the top tile in the open list, whatever that is. We want to push that onto the path list. So add our top tile of the open list to the path list. That's what we want to do. And the way to do that is we're going to say m_p path list, and we're going to push back the m_p open list and the first tile in the open list. Okay. And then what we want to do is, of course, we want to m_p open list. We want to pop back the open list, which basically removes the top tile, right? And why? Because now the top of the open list is something that we're going to be using over and over again as the lead tile that we're going to be using. So the top of the open list is going to be something that we're going to be creating. All right, and then step 2E, we're going to add the minimum tile, right, to the open list, right? And that means m_open list, right? We're going to push back the min tile. Okay, and this is what might be causing our issue, which I'm going to come to in a second. We're going to also say that min tile set tile status to open, because that is the new tile that we're looking at, the next tile basically. And min tile, remember what min tile is. We found the minimum tile based on the minimum neighbor from the original one. Again, going back to our little diagram, we looked at all the neighbors, top, right, bottom, left. We decided which of these neighbors is the minimum neighbor in a right winding order, right? And let's say, for example, we decided that this one is the minimum tile. So now this is the min tile. It's going to be in the top of the open list. And now when we loop back again, this is, we're going to check all of its neighbor tiles. We're going to see that we're going to check this one, this one, this one, and this one. Well, this one now is going to be open like this. It's going to change to open, right? This tile is going to revert to open. That's going to be, we're going to change that number, right? Or the thing, because we're in this position. This is going to be open because we've already gone there. And we're going to check this one, or this one of those three tiles, right, as the shortest tile. Which one is it going to be, right? We're looping through and we're going from one tile to the other. That's what this is doing, this open list. We're marking the min tile, whatever that is, as open. And then we're saying, hey, neighbor list, here's our neighbor list. Let's erase that neighbor list from remove the minimum tile from the neighbor list. So I want to go to the neighbor list dot begin. So the beginning of the neighbor list. This is an iterator, right? And we're going to add the min tile index, and this is the index of which tile we left this for loop with. Remember, we were looping through, and we're saying we're incrementing the minimum, the neighbor count, and we're also setting up the min tile index. We're keeping track of the min tile index that we found. And every single time we loop through for each neighbor in the list, we're checking that that neighbor has the minimum distance, right? As an example, if we found the minimum distance, then we set that neighbor as the minimum tile, and we also want to keep track of its index inside of the list. So we're saying, okay, go to that list from the beginning and add the minimum tile index, whatever that is. We want to remove it from the list, and we're removing it because we don't want to add, this is a prep step for the next step that we're doing. So step 2F, where we're saying add, push all remaining neighbors, let's say we have more than just one, onto the closed list, because we don't ever want to see those neighbors again. They're like more expensive from a distance perspective than the neighbor we already found, and those are going to be on the closed list. We're going to say for each, right, again, for each neighbor in the neighbors list, whatever's left in the neighbors list, neighbor, for every neighbor in the neighbor list, right, that's left, I want to check if my neighbor, the one I'm looking at, if it is get tile status, if it is unvisited, only if it's unvisited, not if it's infinite, if it's an impassable tile or some other status, only if it's unvisited, we want to get the neighbor and set the tile status to closed. Only if it's unvisited. If it's open or a goal or a start, we don't want to change that. And we're going to say that m_p closed list, we're going to push back the neighbor that we just found. Why are we, there might be some neighbors in the neighbor list that are unvisited, and if they are, for whatever reason, or sorry, if they're closed already, we don't want to we don't want to add already closed tiles to the closed list, because we'll have this list have duplicates. We don't want that. Okay, so this does most of it, but there is a bit of a problem that Alex found, and the bit of a problem is a bit of a glitch actually that happens, and I think I know where the glitch is. Correcting it is another matter. But basically the glitch, and I'm going to show you the glitch before I correct it. Basically what the glitch does is, as you march around, and somewhere in here and in here, what's happening is, okay, let's look at let's go through the code a little bit so to understand. first thing is we set the start tile as the open, we set it to open, and we add it to the open list. Okay, cool. We search through all the tiles in the open list until either the open list is empty or the goal tile is found, right? And we look through, we set up the number of neighbors. We did that, the valid neighbors. We exclude null pointer neighbors and neighbors that are impassable. We did that. Then we have for every neighbor in that valid list, right? Then what we say is, okay, is the neighbor a goal? If it's not the goal, then figure out the minimum distance from all the other neighbors. How about if it is the goal? And this is where the problem happens. When we find the goal, we do two things here, right? Here's where it goes crazy. Then what we do is we say, well, we found the goal. So if we found the goal, exit from this for loop and push the goal onto the path list. Push the goal immediately onto the path list because the goal has been found. Well, we push the goal onto the path list, and then, well, we keep looping, right? We loop back up here as an example. But before we loop, we go back up to the top. We say a couple things here that happens. We say path list push back the open list, and the open list was the start tile right now. Okay, but if we found the neighbor list, the neighbor tile first before the start tile gets added, and this is where, let's suppose, here's a case where the goal tile, for whatever reason, right, is right here. Let's suppose they're next to each other, right? In this case, what's happening is I go to the top tile, the right tile, the bottom tile, and the left tile. I go to the top tile. Okay, I find that that's the minimum. I go to the right tile. Oh, I find that that is the goal tile, and I stop searching. So I've put on, now let's look at this, what's happening. Here's the open list, right? And here's the closed list, right? So I say in the open list, let's take the, if you notice, right, the open list here at the top, we added in the open list the start tile already. So in the start tile is in the open list, there's start, okay? Take a look at that. And then, right, we go through, we check all the neighbors, and as soon as we find the goal tile, there's the minimum tile, we add it to the path list. Okay, so path list. Okay, we have the goal tile in the path list right away, before anything happens, before even this gets onto the path list, right? So we add it to the path list, yay, right? And then what we do is, after we add that to the path list, we pop it up the open list, we get rid of that in the open list. So this gets popped off, right? We add the open list, whatever's in the open list, to the path list. So we say, okay, S goes here, and then we pop this off. This is the way the function works. We popped it off, and now the open list is empty, and the closed list is empty, right? And then we go through and we say, okay, now in the open list, push back the minimum tile. Well, the minimum tile happens to be the goal tile, right? So in the open list, right, which is the goal tile, there we go. And then in the minimum tile, style status is open. So this changes to open, right? Look what happens, right? And then in the neighbor list, erase that tile. We did it. And then we loop through all of this stuff for it to happen. So what happens is the goal tile is first and the start tile is second. That's what happens with our code the way it is, right? And let's move this over one more spot. So let's move it here instead. Okay, so let's look through and do this whole exercise again to make sure our code is working. You can clearly see this is wrong. Okay, this is not right. And so what's happening is, okay, we go through, we have our open, we put, let's go back and switch this up. So our start tile goes to the open list. There's our start tile. That's the first thing that happens. Okay, cool. We search through all of our tiles, right? We find the minimum tile, which is this one. This is the minimum tile, right? And then we take that min tile, going back up, here's our min tile. We don't do this yet, okay? We take the min tile, here's our min tile, and we say, okay, cool, that's awesome. We found the minimum tile, and we pop off the thing that's on the open list, which is our start. Take that, and we put that in the path list. That works. We can put that here. and we move that from the open list, no problem, right? And then after we do that, we push back in the open list the minimum tile. So the minimum tile goes here. So this is tile 2, 3, that tile. That's the minimum tile that we put in there. Cool, cool. We did that. Open this. Then we take the minimum tile, set it to open. Good, good. We erase it from the neighbors list, and we set up all the other tiles as unvisited. So we said this one, this one, this one. These are all closed. This is open. That's what we're doing right now. And then we push it back to the path list, right? At some point or another, we must push the that new tile to the path list because it's the minimum path, right? Which is right here. Look, step 2E, we take the minimum tile, push it to the open list, right? The path list has the first tile, the last tile that we had in there, but we never push the minimum tile to the path list yet. We iterate again, we go back up. So this is what the path list looks like. We have S, the start tile. We iterate again, and we go up, we go back to the top, right? We go to this point, and we come back in, we set up all the minimums and everything else again. We loop through, get valid neighbors. So here we have valid neighbors. This one's valid, this one's valid, this one's valid, this one's valid for this one, right? And once we're in here, in this particular case, we notice that one of them is the goal tile, this one. We immediately set it up to the path list. Path list now is goal tile. Start goal, right? And after we immediately set it to the goal tile, then and only then do we go and do the next part, which is, okay, path list, push back, the open list. The stuff on the open list is this one. This goes over here, right? And that's our problem, right? This switching and ruining that we're having right now. We push it to we need to be able to take that goal tile where the goal tile is found, and we need to switch these around so that the goal tile gets added in, as an example, but it needs to be added in after the path list. Okay, so how do we do that? Because we're pushing back the open list every single time. So what Alex has done is he's got a bit of a hack that does that. I'm not going to debate, how to do that right now. But what he's done, and again, we can work around this logic later on. What he's done is he switched around the last two tiles. All right, that's what he does. So here's his little hack. Okay, I'm just going to put it in here for you. This is a little hack. And I put Alex's hack because it's a problem with the algorithm. It's clearly he found the problem with the algorithm because it's exactly like that, right? So Alex's hack basically says, hey, let's look at the path list at the second last tile. So we're looking here. This is the path list. Look at the length -2, right? There it is. We're looking here. And he says, okay, make that the goal. It is, right? And then erase that object from the path list. Remove it. So it means that take this away and take this one, put it there, and remove that altogether. So it's gone from the path list. And then after he removes it, push it back. So do this, which is a swap. He just swaps it out. And so he has the proper thing happening at the end of the path. And it's a hack that I like, but we're going to have to figure out a better method in the future. So that's what that little hack does. Okay. And I think it's valid. I think it's a valid hack. After this, what we really want to do, and then by the way, this is outside of the while loop, because the while loop's been done now, and everything has been found. We want to display the path list here. That's the next step that we want. We want to display the path list next. Okay, if that makes sense. All right, but the display path list doesn't do anything yet. But let's put this up, this monster of a method, which is find shortest path. Let's put that up on GitHub. All right, so again, save, go on GitHub desktop. And what I want is to, we'll say, added find shortest path to placing. Guess what we did? Commit to main and push. Now we haven't tested it yet. And the way to test this is there's a couple things I want to do. First, I want to display the path inside the console. And how do we do that? Well, that's pretty simple. What we're going to do is we're going to say for each, again, we want inside of the path list, for everything that's in the path list, for every, again, we want to say auto, and the element is going to be a tile. For every in the path list, right, I want to create an entry on the get grid position. I want to create an entry on the console. Ooh. And then also I want to show my path count. How big is my path list? So path length. This is part of your requirement for your assignment 2, m_p path list dot size. And because our path list is tiles, we can count a number of tiles, 5 tiles, 10 tiles, 20 tiles, whatever that is. We're not actually counting up like the distance in terms of a numeric distance. We're just counting tiles to get to that end. Okay, so that is what this does, right? And of course, we need a method to trigger this, which we're going to do in IMGUI. So this is where I'm going back to adding the button where he had already added it in his version. Okay, so I'm going to go to IMGUI. And then down in here, what I want is a button to add in the GUI function that is going to be the find shortest path button. So I have a separator, and underneath that, I want to make another one. Let's make another separator. And we're going to use a button. So we're going to say, I'm going to make an IMGUI button. So if, and it's going to be IMGUI button, find shortest path. If that button is clicked, then what do I want to do? I want to m_find shortest path. That's what I want to do. And okay, this is pretty cool. Let's run it and see what happens if we can actually make this work. So again, we open it up, we toggle the grid on, and we find the shortest path, and you can kind of see where the shortest path is. It found it right here across and down, but it'd be great if we could actually color this up so that it can be shown similar to what Alex did with our little color. And I'm going to make a change to what Alex did again in his thing. But again, thanks to Alex for doing all the stuff. We have inside of our function already a switch case in our draw. In the tile.cpp, we have a switch case. Let's add to the switch case. What we're going to do is we're going to say two things. We're going to say case, if it's the open tile, then draw something different. And case, if it's a closed tile, then draw something else. We just converted our if-else to cases, all right, like we did last week, right? And I want to draw the same thing. So I'm going to use the draw filled rect. Let's put that down here and down here. And I'm going to say that when it's closed, let's make it so that it's a dark gray color. And when it's open, let's use a light gray color. A light gray color is 0.83. That's a light gray color. Like so. And that function, the draw function that I have here, yeah, I'm going to go better there in a second, Rakib. This display, or the draw function in the tile.cpp file, is the thing that's going to help us display everything. Okay, let's go back to that display path list is what Rakib wants. Let's go there. So display path list. There it is. Tile draw is being called by the scene. Okay, so the scene.cpp, verb place scene.cpp, what it does, right, is it calls, if I go to the draw method of the tile scene.cpp or the place scene.cpp, it calls draw display list. Draw display list, if I go to definition for draw display list, is part of the scene superclass. Where draw display list, there's a scene superclass, loops through each of the objects that have been added to the display list through the add child function and calls the draw method on them. That includes the tiles. Each tile is going to be called here in the draw display list function. Okay. Hopefully that answers your question. Let's try this out and see if it works. So again, we're going to go through here and we're going to open this up. And if I toggle grid, there it is. And if I press find shortest path now, then bam, we get all of this that happens, all of this. Okay. And yes, this is cool, but it would be nice to see the values underneath, which would be nice too. Okay. So how do we change this? Because each of the tiles, right, in the tile list is up here. So let's go to my tile.cpp for a second. Notice that each of these is being printed. Okay. And the default case is printing out get transform position, get width, and get height. That's what's happening here, right? And everything else is printing as possible. This is the light gray color, this is the dark gray color, and all these are 111. Okay, that's the draw function that's happening. Okay, for each tile. And the rest of this whole thing, right? Really, if you think about it, when we add the labels and everything else, so we added labels to the tiles and all that kind of stuff, that gets added. And what we want is the order of sorting. The sorting order is for the labels and for the set labels enabled to be added first, right? Before it prints out that value. Okay, that's what we want it to do. So that is could be a factor of the place scene, right? And if we look at the build grid function, just as a second, let's go look at the m_build grid. Here's our build grid method, right, of the place scene function, just to show you how this works. And this is to answer some of the questions I'm getting, right? If I go to build grid, then in build grid, what I'm doing is I'm looping through each tile. And what I'm saying is, get transform position, world position, right? Set the grid position, column and row. And then look at this. Here's a difference. I'm setting the parent, I'm adding the labels, and then I'm adding the tile. I don't want to do this. If I did it the other way around, if I add the label second, let's say I want to switch these around and I add the label second after I add the child, like this, right? If I did this scenario, because everything goes in when I add stuff in, I add it in layered order. If I run it again, and if I go back out to the tiles, and if I click on toggle grid, and then I find shortest path, then we see them too. Okay, and this is beautiful because what it allows us to do when we do it this way is it shows us the entire grid here, so we can visualize very clearly what are closed and what are open tiles. And this is, again, thanks to Alex for giving me the idea for doing this, right? So if I try it again, let's try it again, and let's move things around as an example this time. And let's move these things around over here and over here. And let's see if I can do the same thing. If I can find the shortest path from here to there. Let's do it again, find shortest path. You can see that it goes like this, right? And notice that in the console, it also shows you the shortest path plus the total path length, which is 25. And it counts down every grid space to find the shortest path. That's what it does. So very, very cool, right? Let's try that again one more time. And let's use a different method. Let's use Euclidean distance as opposed to Manhattan distance. And let's just find the shortest path with this one. So you can see that here it does that whole stepped thing that I talked about in lecture, where it kind of steps through, and finds the shortest path. Okay? Clear? So let's are you with me? Check mark if you're with me, X if you don't know how that happened and what I did and how did I make that printout in the first place. Rakib is good. Thank you. Ethan and Chris Haj. Anyone else? Or just those 3 or 4 out of 13 of you? Okay. That's, it's pretty low still, guys. I'm concerned. What about the other guys that are here? What about you? How is it that you don't understand? Is there an issue with some of this stuff? Or have you not been able to make it work? Stanislav says, I can't put check mark to view debug. Can't do that. That's interesting. I don't know why. Was that a problem before? Because we haven't changed any of that stuff. And remember, anything that happens there, that's inside of the IMGUI function. If I go to the IMGUI function right here, that is all in here. All I did for the IMGUI function is we have our toggle grid. I haven't changed that. I just added a separator here, right? And I added another separator underneath the find shortest path, right? You can see that I've done that too. And that find shortest path separator is what's saving me, what's pulling this together. Now I know I need a couple of things here. I know I need a couple of, can we change what button opens IMGUI? It's the backtick character right now. That's the button that opens IMGUI. Why? Why is that? Why do you want to do that, Rakib? Yours freezes when I click find shortest path. Okay, but in order for it to freeze, there's got to be a reason for it freezing. So you need to do some troubleshooting on that. But yeah, you can certainly change the button. The button that I'm using is the backtick character, but you can change that to whatever character you want. Just wondering if it could be assigned to another button because I have a smaller keyboard and the shortcut is uncomfortable. Smaller keyboard. Oh, you're talking about in the top left corner instead of escape. Well, that would be inside. If you're going to change something like that, that would be in the IMGUI function. So IMGUI function is called right here, this one. But the IMGUI function is the GUI function that's being called in the start method. So if I go to start, then at the bottom of the start method, I've said the IMGUI window frame instance, right? Let's go to that function, that class. The IMGUI window frame class has an instance method, which because we're using it as a singleton. And inside here, we have we're waiting for an event to open it up, right? And I'm pretty sure it's in this IMGUI window frame function on the CPP side. Let me just make sure that it's here. It opens up a new window. And I think, if I'm not wrong, we have a render and we're waiting for a window to open, or it could be in the event. I think it might be in the event manager if you really wanted to know. Again, it's a little bit off topic, but I will do my best to get us back on track in a second. So here's the event manager, right? In the event manager CPP, I'm pretty sure we have an event that opens up that window. Set mouse motion, set mouse button, set text input, set key down, and there it is, SDLK backquote. So it's on line 70 of the event manager. You can change that to whatever you want. Instead of your key symbol being backquote, which is that button, you can change it to whatever you want if you don't like it. Okay? No problem. All right. Blah, 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 blah. Okay, so that was our tile. So we changed the way the tiles look. And we did that by doing this. We changed the way the tiles look, which is pretty cool. And what I want to do now is let's continue putting some more things inside of IMGUI, the IMGUI function. So I'm going to go back to the IMGUI function, and we know we're going to need some controls in here as well. And the reason why I'm going in here in the IMGUI function is because I want to prep for more things. We need to reset our stuff. That's what we definitely need. We want to be able to make our ship move. That's the next thing we're going to do, right? So underneath this, the find shortest path separator, right here, I want to add another button. Okay, and the other button that I'm going to add in IMGUI is going to be the start button. So there's our start button. The start button is going to start us on moving our ship, and the way it's going to look is we're going to say if not m underscore ship is moving. If it's not moving, then I want to make the ship move. Okay, we're going to make it move, but only if it's not already moving. All right, so that's what that does. I want to, on the same line, I'm going to use IMGUI same line. On the same line, I want another button, which is going to reset our, we're going to have it reset pathfinding. Okay, that's what it's going to do. So let's make another button. We're going to call it reset pathfinding. Okay, and we're going to call the reset pathfinding function m underscore reset pathfinding. Want to do that for sure, right? And I want another one on the same line, which is our reset simulation. And there's going to be a difference between one and the other. Simulation. Okay. So reset pathfinding, reset simulation. And this will be calling the reset simulation over and above what Alex did. But again, very similar for the most part, right? Nothing else is really changing here than these things. And those two functions don't work. This doesn't, our move ship doesn't move anything. But if I go back to IMGUI now, then you can see that when it comes up, I have these extra buttons, right? Again, the start button and the reset pathfinding and the reset simulation button don't do anything at this point. But we can still decide I want to use the Euclidean distance and find the shortest path, right? What I want to do is, what if I move this thing over here, right? I want to be able to call find shortest path again. Right now, if I do that, it doesn't work. And I want to be able to reset in order for me to do that, okay? Okay, so pretty cool. So now let's move the ship. Let's move the ship next, because that's the next thing I want to do. Maybe what we should do is do a GitHub push again, just because we've made some changes. So again, GitHub desktop, let's push that up. And I'll say the things we changed was we modified the tile to show the grid, show the thing in the grid, right? So we said modified tile class to show the shortest path, right? Shortest path. That's what we did. So commit to main and we push to origin. There we go. Thanks, guys. All right, and I see some thumbs up. I'm seeing some thumbs up in the on the YouTube side. Thank you very much for that. So that, yeah, that's pretty cool. What we want to do here, we want to be able to move things now. So let's go to that part next. So I'm going to go to the move ship function. There's my move ship function. Notice it's pretty lonely. And what we want to do with the move ship function is actually make the ship move around, right? So that is the next thing we want to tackle. All right, so how does the ship move around? Well, I need to use an auto offset. By the way, I tried to fix the auto offset earlier to comical failure. I'll talk about that maybe another day and how to fix that problem. But what you can do is we can get the offset from start, because we have a start offset. And I want to go back to the move ship and just pop that in, because that's the offset function that we put in there last time. The offset, because we're going to use that offset, because remember we moved something on the screen, we want to offset it so it's in the middle of the tile. That's what the offset does. we're going to say if move counter, m underscore move counter, if that is less than m underscore path list, this one, dot size. So we're going to say if the move counter right now, move counter starts with 0. If it's less than that, then what I want to do is move my ship around, right? Else, if it's not less than that, if it's equal to, the move counter's met the size of the path, we don't want to move anymore. So we're going to say m underscore ship is moving. We're going to set that to false. We're going to turn it off. That's what we're going to do there. But if it's not, if we haven't gone through the entire path, we want to use an auto. We're going to call this path tile grid position. The path tile grid position, and maybe we'll make it this time around, we'll make it a little bit closer, so just save space. The path tile grid position is going to be, we're going to set it up as m underscore, we're going to call this p path list, and we're going to look at the move counter, m underscore move counter, right? And we're going to say that let's get grid position, and that is going to be the path tile grid position. So wherever the path list is, we're looking at the first tile in the path list. That's what this is, and get that grid position. The reason why I know it's the first tile is because we started our move counter in the placing.h. We set it up as 0. I'm pretty sure. Right, there it is. That move counter is set up as 0. All right, so that is the first piece. So this is 0. So the first tile in the path list, that is and we're getting the grid position of that, and we're setting that up as the first thing. And then we're going to say m underscore p spaceship. We want to move this thing. We want to get transform dot position, and we want to say that that is equal to the tile m underscore get tile, where the path tile grid position is. So I want to pass the grid position of the path tile, the current path tile, into get tile, which is going to give me, and I want to get out of that the current transform position, the world position, right? Plus an offset. So this is great if I had a utility method that would do this kind of stuff for me. We've done this a bunch of times where I said I want to go from grid space to tile space. Grid space to world space, right? I want to go from world space to grid space, right? So that might be 2 little utility functions I could have later on. Ethan, can't we just make it reset when we click the button again? No. Because, well, we could. You mean the start button? We could. But I'm giving you a reset button altogether, a separate button for that. But yes, we definitely could do that. M underscore P. Now that we've moved the position of the ship, we want to set its new, we want to set up its set grid position. So we kind of mark the grid position as we set the path tile grid position, take that grid position, dot X, and we get the path tile grid position dot Y, whatever that is, and we're going to set that as the new grid position for the ship. Then, and only then, when the game instance, we're going to call the game instance. There's a utility function that I set up with Alex called getFrames. We're going to get the total number of frames that have elapsed from the beginning, and we're going to divide them by 20. If the remainder is 0, that means for every 20 frames, we're going to wait 20 frames, and every 20 frames that goes on that the move ship function is called, I'm going to call the move counter plus plus. So I'm going to move the counter again. And what this is going to do is, when we loop through here again, it's going to move the counter 1 step. It's going to go down here, and it's going to move the path list. It's going to change the path tile grid position to the next one, and it's going to move us to the next one, to the next one, to the next one, to the next one. That's what it's going to do. Okay? Awesome. So that's what's happening here. Now, optimizations. Later on, we could probably wrap this whole function in something that looks like this, because we don't want to even get this ship and do all this stuff unless we waited 20 frames. Okay, so we could probably wrap it, and then I'll do it afterwards if we have time. All right, optimizations. But that is the move ship function. Let's check it out and see if it works. This should be working right now. So if I run plus play, and if we go back to the grid, see the grid, find the shortest path, click start, we'll have that ship move in no time. Look at that. Clickety clack. It's going to move down the track. But it doesn't change facing because we haven't coded it for that. When it turns the corner here, it doesn't change the face where it's looking. Okay. Okay. Makes sense? So that's what it does. Now what I want to do is I want to be able to, if I click start again, well, there's no place for it to go, right? There's no place for it to go. I can't find shortest path again because that is not going to happen. So it can't find shortest path, right? I need to reset, right? And that's the next step that I want to do. I want to reset this, but I don't want to reset the ship. If I move the ship around now to here, I want to be able to find the shortest path again. So if I click find shortest path, it should work, and it shouldn't like lock me out or cause a problem, right? And the reason why I can't do it now is because we already have an open list and a closed list, and all this stuff is here. I got to erase the closed list and the open list in order for us to move forward. Okay, let's put this up on GitHub first. So again, GitHub desktop, we're going to say added ship movement. So commit to main and push to origin. Awesome. Next, let's reset our pathfinding. And this is where we are going to talk about it a little bit. So reset pathfinding. And reset pathfinding, Alex had it in 1. I'm going to make it slightly different. So first what we want to do is we want to clear the tile vectors. Clear the tile vectors. And we want to remove everything from the path list and so on. So we're going to say m_p path list. We're going to say clear. We're also going to shrink to fit. And shrink to fit, what it does is it removes the whatever size it was, it makes it go down to 0, right? And I want to do the same stuff for the open list and the closed list as well. Okay, let's do that. So we're going to go here and we're going to go a couple times. So this is the open list, m_p open list. And we're going to do the same thing for the closed list. This clears up the memory that we had from before. And then what we want to do is we want to reset the statuses of our tile statuses, is what we want, across the entire board. Let's reset them. And so for that, we're going to say for each, and we're going to say for everything in m_p grid, this one, we're going to change this for every tile in the grid. For every tile in the grid, I want to say that the hey tile, I want to set the tile status to unvisited. For every tile in the grid, let's set it to unvisited. Okay, so it sets it up again. All right, now this is the tough part, which always kind of messes me up. Reset the goal and the start tiles to where the ship and target are currently located. Okay, and I'm going to do m_get tile, and we're going to look at m_p target, get grid position, right? And we're going to set the tile status of that tile to the goal, because that's the target, where the target is. So we're going to reset the goal wherever that is right now. I want to do the same thing for the ship, m_p spaceship, get the grid position and set the tile status to the start. There we go. Start and end goal are set up, right? And then what I want to do is I want to mark the goal position. Remember that goal position? I want to mark goal position 0 as the new M underscore P target. And then we want to do get grid position dot X. I want to do the same thing on the y-axis. So I want to kind of set the goal position. These are our kind of class variables that we use to set up the goal position so that we can show them on IMGUI. That's what this does, okay? And let's do the same thing with our spaceship. So we'll set the spaceship up that way too. Instead of the goal position, this will be the start position. Right? And this will be the for the spaceship, not the target. Spaceship. Okay? So that's just basically communicating the actual position of the ship to IMGUI. That's what it's doing. Okay? And then we'll set the move counter back to 0. M underscore move counter, set that back to 0. And we'll also say that the M underscore P spaceship is moving. So ship is moving. Oh, ship is moving. We should actually have a B in there, is equal to false. So we'll set that up as false. All right, so that's the little reset function. And there's two ways I want this reset function to work. If I move my, if my goal is moved around, I want this reset function to immediately work. All right, so that means in the IMGUI function, let's go back to the IMGUI function. When I move my goal around, or my ship around, really, if I move my ship manually or my goal manually, I want it reset. So I can do that. Any one I set up, I'm going to say, let's reset pathfinding. All right, because if I'm moving it around, I might as well reset the pathfinding. I'm going to do the same thing with this, M underscore reset pathfinding, if I do it there too. Okay, so anywhere I move any one of these two things, I want to reset pathfinding, or if I press the button. Let's run that simulation and see what happens. All right, so toggle grid on, find the shortest path, and start moving. We start moving, all this still works, right? Notice that in here, when you move the plane, the ship, it actually moves the dials on IMGUI as well, which is pretty cool. All right, now I'm going to move one of the things, either the ship or the target. And if I move it, it automatically resets everything. And if I did everything right, I should be able to do find shortest path again and start it again. So it'll start going this way again, right? So that's pretty cool. So I can do it this way, where I can move my stuff around and find shortest path again and start again and move back, right? So I can do it this way. That's what the reset pathfinding does, where I can manually kind of move things around, or I can press the button. It doesn't really matter. And then find the shortest path and start again, no problem, right? Or I want to be able to reset the simulation back to where it was before. Okay. All right. So how do I do that now? Well, let's first put this up. This works. So added reset pathfinding function. Okay. So commit to main and push. That does a lot of it for you right there, guys, for things. What did you miss? What do you mean where I put it? Are you talking about the reset pathfinding function? That is just at the bottom of the move functions in IMGUI. So I put it reset pathfinding. Whenever I move my start position or my goal, I reset pathfinding if I do it manually, because then whatever the path was is invalid anymore. It's gone because I moved them around. Okay. So that's when it resets everything, resets the tiles back to what they were before. Okay. All right, the next one is I want to reset my simulation. Okay, so this is the next thing I want to do, reset my simulation. So how do I do that? So resetting the simulation is like resetting pathfinding, but I want to reset the positions of the ship too, right, to their original places, right? Okay, let's go there. So let's say reset simulation. That's a different function. I just call it something else. It's very similar to what we're doing here. In fact, I'm going to use this function when I call the reset simulation function. I'm going to use this function here first. But I also want to have this offset. I need the offset again. let's put the offset back in here. And in the reset simulation, I'm going to call back m_reset pathfinding, right? So first, let's do all this hard work. Reset the pathfinding, set the goal, do all this stuff, clear everything. And wherever my start and goal tile is, I want to do this. So I kind of want to do all of this first. So everything has been reset. Then I want to flash the ship and the target back to their original positions. But in order for me to do that, I need to clear their positions again. So again, there's some duplication here. I could call the reset pathfinding thing altogether. And notice that we also have this clear vectors, and I want to do the unvisited tiles and all this stuff that we did before, because we want to clear all this up. So there's actually a couple things we can do here. It's like this, but this piece right here is going to be somewhat duplicated in here in the next one. All right. So first, let's do a few things. I want to clear the current status of ship and the target tile. That's the first thing. So that means that I want to get the tile for the ship, and I want to get the tile for the target, and then set their status to unvisited, right? So why is that? Because at the bottom of the reset pathfinding function, I set the goal and the start positions already. Wherever the ship was and the target was, I reset theirs to goal and start. So we need to clear this up again. I could call this function again, but that's kind of redundant because I'm calling it twice. So it's like I want to do this and this, but I want to change just those ones to unvisited, since I did the other ones already. All right, so that's the first thing. So make them unvisited. And then I'm going to flash them back to their original positions. So, okay, so what does that mean? Well, we already have some of this in the start method. So if I go back, if I just teleport to the start method for a second, you can see that I have all of this. Set the grid position, we do all this. So I want to grab this part, pretty much, all of this, right? But I don't want to add child again. I just want to grab all this. So this, actually just grab all of it, and then I'll just delete it. Delete the parts I don't need. So let's go back to reset simulation. And down in here, I want to put those in there, right? But we don't need to do this. I mean, I don't need to do this or this or this or this. So the lines, I don't have to type them in again. That's what I wanted to do. There's the offset that we had before and all that stuff. This is all the same because we've moved them back to the original positions in our simulation. And then we need the other pieces. We need this stuff. We need the goal here, where the target is the goal. So whenever we set the target, that gets put in here, right? Because we need to inform I'm GUI, we're moving things around. And the same thing goes with the ship. So I'm going to take the ship, and after we set all that stuff, we want to inform I'm GUI that the ship is moved around as well. And that is really the simulation reset, because I'm resetting the positions and I'm unvisiting all the tiles. I already called the reset pathfinding because it does all this heavy lifting. It does this part, right? As an example, I clear, shrink to fit, make every tile on the screen unvisited, then do some of this, set the counter, and the ship is moving to false, set it all back, which is the reset simulation function. So it's more of a complete reset. Okay, let's see if this works or if it's glitched. And by the way, I did find some glitches when I did this the first time. So if I run it, and if I move the simulation, let's say, for example, this time I want to use Euclidean distance, and I want to toggle the grid on, and then I want to find the shortest path. There's the shortest path. And then I want to start. Then it's going to move everything. Notice that I'm GUI moves along with it. And if I click on Reset Simulation, it's going to reset back to the way it was. And then I should be able to find the shortest path again and start it over again. That's what the Reset Simulation does. So it kind of goes back to the original way it was. Okay, cool. That's great. What if I just don't want that? I want to reset pathfinding now. Okay, so reset pathfinding. And if I move these things around and then find shortest path, I should be able to do that as well and start. That might be another way of doing it as well. And the last way to do it is if I actually physically move my stuff myself. So if I move this up over here and move this kind of up over here and then find the shortest path and then start, then I should be able to do it that way too. So there's a couple of different ways I've done this. This is, reset simulation. Let's do that and put that up on GitHub. So again, going back to GitHub, I'm going to say added reset simulation function. All right. Questions so far? This covers everything that's inside of your lab. If you look at the lab report that Alex has posted, which is pretty good. So if you go back up to the lab report, it covers all of this. And now for you to add, you need to make some tiles impassable. And then what you need to do is ignore the impassable tiles in your find shortest path. I kind of did that for you. And this is for you to figure out, but I kind of did that already. And then it says, yes, you must get this to work and demonstrate the altered path and a final commit. This is for students to add. But I got some time and I'm going to kind of talk about how to add some. And I want you to add more. Your job is to add more than I'm going to add. Okay. And how do you add? So here's the question. How would you add impassable tiles, as an example, to your simulation? Let's go back to where the simulation starts. So remember, it's 1 and 3, and then it's 15. Remember where it is? If I go back to the original thing here, right? It's 15 and 11. So 15 and 11, which is this spot right here, this spot, right? That's 15 and 11. I want to move this to 15 and 11, right here. Okay, and I want to make this, let's talk about this as being blank. Okay, so let's add some impassable tiles. Let's see how this works if I want to add impassable tiles to my screen. So I want to add tiles, impassable tiles to, let's say from here to here. How do I do that? What is your solution, guys? How do I add impassable tiles in there? What are your recommendations? I'm going to talk about it, right? It's not that difficult to do. All you need to do here for impassable tiles is you need to add some tiles that are marked impassable. How do you do that? How do I specify which tiles are going to be marked impassable? Coordinates, yeah. Tile status, yes, good. Get their X and Y on the grid. X and Y on the grid, Tarif, right? So again, what we can use for this to give you an insight or hints on how to do this is you want to use the get tile function, right? Remember that when we get our get tile function, the get tile itself, right, it gives you the grid position of whatever you're looking at. So you can put in the grid position. You can put it in either in X and Y coordinates, or you can put in the grid position in there. So if I wanted to add, let's say, an impassable tile as an example at position 4 and 0, then what you would do is something like, let's do 1, okay, and then I want you to think about this on your own, right? So let's go to start method. So I want to add an impassable tile here. Let's just say I recommend a function. This is impassable tiles, and inside here you'd add you would add a function here, add function here that basically sets up impassable tiles. Okay, and you would have another function. Let's call it something like set impassable tiles, right? And then this way you can map the exact thing you want. And let's say we'll just do an example. Here's an example, right? So I want to say m underscore get tile, and I want to get the tile at let's say it's 4 and 3, 4, 3. I want to get the tile at 4, 3 and make that impassable. All right, get the tile at 4 and 3, and then I want to set tile status to impassable. Excellent. And this is one step. So if I was going to do this now, let's see how that looks. So if I run the simulation, that's how you would add an impassable tile. This is for you to do, right? If I toggle the grid, you can see that there's clearly an impassable tile there now at 4, 3. See? Nice and easy. Okay, but it would be nice if we colored this up, and you can do that in the tile.cpp, and where you'd have an impassable setting here. And let's make it black. So grab this. This is a freebie for you, right? Where you can say that this is completely black. Okay. I just put this in the tile and then press play. And then when we do that, if I click toggle grid, you can see that there's a black mark. There's a big black hole now in the middle of our tile. So now the path should change, right? And now we can do some stress testing, right? Where I can say, find shortest path. See how it kind of went around that tile, right? And that's what you want to do. You want to add more paths, more of these tiles to stress test your stuff, right? Let's reset simulation, right? Notice that it also wipes that out because the tile that I put in was only temporary, right? You have to make it so that when you reset your simulation, you also reset all the impassable tiles to where you want them. Okay, so that's how it works. And if I was to do it again, one more time, this is the last thing I'm going to show you guys. Let's toggle the grid on. There's my impassable tile. And let's pull my ship up there. Notice it resets my simulation, right? Because it takes away that. If I move my ship around, it resets the simulation. It just does, right? It's just unfortunate because that's what it does, right? So let's try that again. Let's try that again, and let's use Euclidean distance instead of Manhattan distance and see if it does something different. So find shortest path, and you can see that it just does the exact same thing as Manhattan. So some stuff for you to do, all right? Question around this. I'll put this one example up online for you. So again, we'll say added impassable tile example, right? You have to do the rest. And I want you to do some stress testing, guys. Make sure that, this path stuff works before, your stuff that's coming out for assignment 2, which is when it's due. Any questions at all around this? And because this is kind of the end of our day. There's no questions. What I'm going to do is I'm just going to briefly look at the report to show you what it looks like. So let's go to the report. I'm just going to pull it down from in labs. This is where they are. Under here, there's the lab report document. And let's just download that and show you what that looks like here so we can see what it has. You have a question about assignment 2. Okay, hold on. So this is lab report for lab 5. Version control is 0.5. Find shortest path is 1. If you did that with me. Display and reset path is 0.5. Impassable tiles is 1. Display and reset path is kind of the reset that we did, right? I'm GUI controls is 0.5. Impassable tiles is all you. Just adding one tile is not good enough, all right? So they're not random. They're implemented without flaw. And that means you have to have some kind of function that does this. It's worth 1% of your final grade to do your own impassable tiles, guys. That's what I'm looking for. Make a small little stress test your map, right? Ship movement is worth 0.5, and there is a bonus part, and the bonus part is random impassable tiles that exclude position of the spaceship and target so that they don't clobber the spaceship and target. That's also worth an additional 1% bonus. So if you didn't do well on one of the other labs, this can give you 5% instead of 4%. Okay, that's what this is. When and only when the debug view is active, the user can left-click on any open tile in the debug view and select it as the starting tile. This will become a unique feature of the debug state. What does that mean? That means that we haven't implemented this. This is for you to do. If we're going to go, this is for assignment 2 question. So if I run this thing as an example, and instead of me moving the starting tile by doing this, right? you can click anywhere. If I open up the debug view, which is toggle grid, right? If I click anywhere in the scene itself, it'll pick up which tile I'm clicking on, right? And make that the start tile. It'll teleport the ship to that position. That's what it means. Okay? And that's part of your assignment too. And how do you do that? How do I know where I'm clicking? What is this what is this a combination of? It's a combination of, yes, SDL mouse position. We already have that because remember, in the scene, right? So if I go back to, let's just close all these things. We don't care about these anymore. So we'll close all tabs, right? If you go back to the scene itself, which is here, so the play scene, .h, notice that you have a mouse position. There's your mouse position. So in your mouse position, this is pretty cool. You grab your mouse position, and that is the X and Y position of your mouse, right? Your mouse position is set up already because inside of the start scene, right? Remember, we can get our mouse, this is right now it starts off as 0, but where do we initialize this? Well, let's take a look at the playscene.cpp and start taking a look, right? So where is that mouse position ever set up? So if I go find mouse position, right? Where is it? There isn't anything set up. It's there for you, but you haven't set it up. How do I get the mouse position? Well, we know that inside of the in singletons under game.h and game.cpp, game.h, notice it has a get mouse position method. So you can call the game instance get mouse position to give you the X and Y coordinates and store them in your scene inside of mouse position as a temporary variable. I recommend that, all right? And then once you get that mouse position, you have to convert from world space to grid space. Wherever I'm clicking in the mouse, I want to convert that from world space to grid space. And then we have that conversion, m_get_tile, right? I want to convert that. When I convert it to grid space, I want to change the position of the start tile to that tile, and I want to move the ship, your ship, there. Guys, one more thing before we go, I want to mention. Okay, please, always take a look at the requirements for your assignment. If you look at the requirements for assignment 2, remember, you're going to get marks based on what it says in here, right? So it says start scene is okay. You must include a tile class. You must include a grid and tiles you will use for pathfinding. Tile object in your map. All this stuff is good. The actor sprite. Create an interesting map. Guys, this is not what we've given you in lab. All right? An interesting map is your own map. You have to have your own way of drawing stuff so it looks good. Okay? And your actor sprite should not be our spaceship, right? Or and the target should not have anything to do with our target, right? Because it has to be exactly what matches your interesting map. If you make it our spaceship, it better be a space game that you're making, right? So the map is black, guys, and that's going to be very difficult to show. All right, so please don't use our spaceship. I recommend if you're going to make a spaceship, make it work okay. That is required, right? As well as your actor. Things we didn't cover is your actor should be using the look where you're going algorithm or something like that, where the actor is looking in the direction that it's moving. We didn't do that in the lab. We did movement, but it's not looking anywhere. It's looking in the original location. We're never turning it to face the place where it's going. Right? So this is something you need to do. These are things. There's also sound effects and background music. This is worth marks. Please go through each of the requirements in your lab in order for you to do that. Okay? I'm not going to go through the rest of it. We've already gone through, but I'm giving you examples of things that you need to put in. Tarif says, when the user presses the F key, your program will calculate to display all variable. Yep. All viable paths. Does this mean we have to create a function that finds every possible path? And this is for the assignment. Yes, you do. All viable paths. All viable paths, yeah. And what you want to find is you want to highlight the shortest path. I already showed you how to highlight the shortest path. Now you got to find other viable paths. If all you do is show the shortest path, you've only done one part of the assignment. Remember, we're bringing you closer and closer to getting the assignment done, right? So that's what this part was. So now, again, you have a few days to get together with your partner and do some coding, right? And try and figure out how would you find all possible paths, right, to the target? How do you do that? And that's going to be, of course, inside of your debug view. All right, that's it for me, guys. Hopefully that helped you out. Thank you so much for everything. I'm going to stop recording up on YouTube, and I'm going to, I've got to go to the next class. All right, Raul, let's see, what's the other, thanks a lot, Raul.